Alright guys, this is Steven from Legit Tech Tutorials and the Green Engineers, and so let's go ahead and start another DIY Metal Router 2 episode here. So we're going to be going through here and finishing and doing some more designing. Last video we had the 800 watt air-cooled spindle. We've changed that inside, get the weight pretty close to what it's supposed to be. It's about a 5-pound spindle. And we have two options of clamps. I think that's pretty much all the clamps that we have, all the 65 millimeter clamp options. Let me see. Okay, same clamp, same clamp, same clamp. Yeah, looks like those are the pretty much the two kinds that we have here. Yeah, that's pretty much it. So we might design our own where we come in and bolt because again, any different size, any much bigger than this, I mean it's already getting bigger than the actual spindle itself. So if there's a way that we could have like just like this is pretty good where it would be the same size as the block. So let's take a look at the block here. The block is 75 millimeters, or so 75 millimeters wide, and this is 120. So it's already bigger than the block. So that's 5 inches wide. It's already quite a bit bigger. Obviously, we have the 65 plus this, so we might go with a bigger block or a longer block on this piece here, but it would use the same rail. It's just a longer block. So obviously that's the CA and then HA, I think. So that's this the HGH20HA block. So that should be okay here. So we'll actually go with the HA block here. So what I'll do is let's go ahead and type that in again. So let's say that this is the HGH20CA Highwind, and let's find one where it displays it. Yeah, okay, this one's pretty blurry though. Can't even make that out. No point in doing that one then. This table's pretty blurry. Back it out a little bit. Okay, let's see, does this have a good table? This has the good table. Alright, good deal. Oops. Okay, there we go. And here we are. So here the HD20CA is 50, so we might go 65 millimeters long. Still, that's obviously we need, this thing is like 120 millimeters. What I would rather it be, so we might, yeah, I think it's worth machining something instead. Instead of doing this here, because this is 4.5 inches. That's a lot of space. And 65 millimeters itself, obviously we could go a little bit bigger than 65 millimeters, and that's the overall length. So that's even more than the mounting. So we might put bigger rails up there, because it needs to be, so 78 is the next size up. That's an HGH 25, which is a 78. Which is 3 inches. So what is 65? So that's 13 millimeters. So that's a 1/2 inch on each side, so we could fit a 1/4 inch bolt. So that is the, what was that one? That was the HA HG25 HA. So let's do that. So let's go ahead. Okay, well we have all of the specs for that. So I think, but it uses a bigger rail though. It uses a bigger rail, so let's just reopen this one. And then this is what we're going to use on the top here. because we want that extra size of rail. but ordering two separate ones, that should be okay. Okay, so we'll just keep the same shape. So this width of the rail, H rail, or width W rail, is 23. So 23 divided by 2, it's 11. 11 and a half, and then height of the rail is 22. Then we have D for that. Okay, so what is E? Does E change? E still 20. Wait. E still 20. P still 60. But D, how does D change? So D is now 11. So D is now 11. Oops. So D is now 11. Oh, and then another thing that I missed. This is also the same, 11.5. There you go. Whatever, it doesn't really matter. Okay. D is 11, and the actual hole size is now 7 millimeters. So this is now 7 millimeters. And there we go. Now, this is an HGR, I think. It's an HGR. Well, it's an HG25. HGR25. Okay, so now we'll go to General Assembly. Now these guys are thicker. So now we might need to make this guy bigger in order to compensate for that. And so now let's go ahead and open up this guy. Oh, actually, let's close this. Let's duplicate it. Copy. Paste. And this one, let's rename this to HGH25 HA. There we go. Super ugly looking, but that's okay. Okay, so now HG25 HA. So height is now 40. What? Yeah, 40 from top to bottom. And basically the height of the thing itself is 40 minus, so this is 40 minus H1, which is 5.5. There we go. And then this is 11.5, right? 1.5. 11.5. What the freak? Whatever. That's fine. Okay, and then width is now 48. Okay, and then I think that's okay for the rail right now. Then on the top, Okay, B, which is the separation this way, is now 35. And C is now 50 for the HA. 50. Okay, so stop that. And now this extrusion is now, oh, this is 100. Okay, so maybe I don't need this, because the other one, the 20HA is 92.2 or 77, so the HGH 20CA is 77, but the L1 is actually only 50, so we need, and that the L1, so we need L1 because it kind of needs to touch down. We actually need B to be over, we need C, we need this one C to be over 65. So, where is C actually over 65? Oh, C isn't over 65 until HGH 35HA. Wow. And that's a huge rail. The thing is 55 millimeters tall. But then if that's the case, if it's over 65, then we're going to lose a lot. So what I'm thinking is that we have to we have to make a mount where we mount it. Let's say there's like the spindle, there's a circular spot, and then there's a little flat spot. A little tiny little square flat spot in it that we can go in and mount this. So, because here, overall length is still over 65. Which it's 77, so that should be okay. So let's delete this. Whatever, save it. Save, delete. Because again, our objective is to have the biggest block possible. So I'm liking this, and this one will basically be an HA block. No, this could be a regular CA block. There's no problem with a CA block. But now we're going to have to revert this. Today, what version am I running on this right now? Version 4. There. Oh, this is a 25 inch. This one. Come on. Yeah, because we don't actually need something bigger. It's not loading. Anyways, I'll roll that back. That's not a problem. So, I'll roll that back when it eventually loads. Or we just change this back. It's not really that big of an issue. This is 10. This is 10. This is 10. And this is height of rail is what? Height. What? Where did it come up with 22? Oh. Yeah, so this is 17.5. Save. And then go ahead and close that. Oh, Jesus. And then this is back to 20. So this is a 20. Cat's getting attacked by something. Okay, so that's okay, that's okay, that's okay, that's okay. So just a little bit of a scare there. So we're going to have to machine our own block just to make sure that we have high yield. as far as space. So, but that means that we could use our standard blocks. So let's go ahead and move this up and out so we can see it. Let's go ahead and joint it. And we're going to click on this guy here. Actually, we're going to see if this is the Y gantry. There we go. And we'll modify joint, edit joint, and we're going to move this guy in. There we go. So as you see, it's already getting close. And we're already going to restrict it slightly by about 12. We're going to lose about 12 millimeters, so it's about half an inch of travel left to right. But as you see, this guy is huge here. We could probably even go with a second. We could probably put a second carriage on here. We could run 2 carriage on here. Just make that super rigid. So that guy could run 2 carriage, but the top we only want 1 carriage. Alright, so that's one. I mean, if it comes with it, might as well do it. I mean, again, we're trying to go for quite a bit of mass here. And it's just going to add a little bit of money. But a lot of rigidity, a lot of extra rigidity. Again, we're trying to machine steel here. Obviously with tiny little end mills, but still. Tiny little end mills and very, very conservative passes. But we're still want to machine steel, so. Alright, so let's go ahead and do our sketches. Because again, this total height is supposed to be 30 millimeters. Let's change this to millimeters. Okay, 39 millimeters, so let's go back 1 millimeter here. It's the Y. That doesn't look right. Oh, well, I guess it is right. Okay, so that's good. Let's go back to the sketch. Project the 2 here. Project here. Minus 3.92 millimeters on the Y. Yeah, minus 3.92. Wait, it was too big, right? So it is plus 3.92 millimeters. There we go. Now it should be correct. There we go, 30 millimeters. All right, so we are good. Let's go ahead and hide that sketch. Go into joint. It's called this joint. This is the x-axis. And this is x-axis driven. Wait a second. That guy's supposed to be down there. This is not supposed to have holes in it. Yeah, 'cause do I want 4 of these? Well, we'll see. We'll see. but that's definitely not right for right now. We want this down there. I just noticed that it's not good. Where is it? Edit joint. What joint is that? Well, let me just edit that joint. Alright, well, let's just rebuild this joint. And we're probably going to have to rebuild everything after it to fix it. Oh shit, what the hell? Oh no, it's right. What are these that are hold? Oh, this is that side. Okay. And now everything's broken. Wait. No, everything's good. Okay, so let's drive these two joints. Edit joint. Let's move them all the way over here, all the way to the end, so that we can do Tiger. You chill out. That's fine. So we can make them kind of pretty close. As far as their starting points. Okay, good. Alright, so now what we're going to do is we're going to make them rigid group, this group, and this group. Okay. Now should beautiful. Nope. Something's not right here. Wait a second. So what do I do with the y-axis? So I did joint. Oh, they're rigid. Oops. This is not supposed to be rigid. This is supposed to be a slider. Yeah, there you go. There you go. Slider. There you go. Alright. I was about to say, I was like, why won't it let me drive the joint? Drive joint. There we go. There you go, little fella. And then this one, we just go to edit joint limits. Oop. So minimum, maximum, standard. Minimum is here or so, and maximum is about there. Okay, so and what were those limits there? 0 by 288. It's the same deal here as 0 by 288 on this one. what's going on outside. Somebody's swimming in my pool. No, it's just my dad doing some pool maintenance. It's like 11 o'clock at night, and it's like somebody's doing something in my pool. Alright, so now let's take a look at total weight. Physical, oops, cancel. Properties. What? Oh, we're in millimeters now. Inches. Properties. We're at 81 pounds with spindle. Okay, and then let's go ahead and look at if we drop in clamp option 1. Actually, let's delete clamp option 1, put in clamp option 2. It's very similar to what we'd be doing. Let's just take a look here. So now we're at like 100 and something. Now we're at about 100. So we got quite a bit more weight that we need to add here to the mass of this machine. It's super sturdy here. We're adding another two pieces down here. So we'll add those later. So those are going to be dual gantry. And because, can we even fit 2 of those on here without losing space? Oh yeah. Oh, but that one's going to be an L, isn't it? That one's going to be a HA. So this is 7.5 inches. 7.5 inches. That's 100. It's 190 millimeters. And these are 92. So yeah, it'll fit about 2. But obviously the grease fittings have to be on opposite sides. Okay, so okay, well that works perfectly and that's with the 2 HAs, I believe. So that looks good. That looks good. All right, so now what we're gonna do is, but in order to figure this out, we need to put on the clamp. Oh, and obviously the clamp. What happened here? Why is this one over there? What the hell? There we go. Now we should be able to drive it, right? Drive joint, back and forth. The other one moving also. Tilt it up a little bit more. Yeah. Okay, so that looks good. Alright, I think we're up to our limit here in a few minutes. So next course of action, to change these. So obviously what we need is it needs to be skinny and have 8 bolts total and go down here, and then maybe even bolt onto this piece to make this extremely sturdy so we don't have any tilt. I kind of like that idea because again it's going to be cantilevered out part way, so that'll change the moment quite a bit and also add more weight, but we'll add quite a bit more cost. It's going to be about another $50 a rail or so for these, so that is another price to pay, I guess you could say. So that is the next deal, is that. So and then add a second one here So add a second one here and add another 2 here. This is fine. So this is about the size of the spindle. Spindle's 65 millimeter, and the overall length of this thing is 92.2 millimeters. So we shouldn't, or 75. So we shouldn't lose much of anything, because again, there's going to be 2 flat holes on this piece in the middle, so we meet the C and B given. So we'll still meet this, and then the piece will go out to the extends here. So everything should work pretty well. And then I think that will make it even sturdier if we add these other 2 rails here. And then we bolt it so that way this is not tilting, and then also we're fully boxed in at the bottom. And so everything works. Another thing is, obviously now we could change how long this is. Nine and a quarter. What was it again? 240 something? Anyways, we'll look at it next video. We'll look at, see how good this is. Alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers. I thank you guys for watching. If you like this video, please subscribe and stay tuned for my next video, probably in another 30 minutes or so. Thanks for watching. Take it easy. Peace.